In this video, I'm going to go over some basic algebraic facts and operations that first semester college students should know. Maybe you're in college this semester for the first time, or maybe you're going to be in college for the first time in the spring. This will give you an idea of some of the things you should already know from, say, high school. And I'm going to have a series of videos on these, so we'll go over about 10 items in this particular video to make it kind of short. And we'll continue with other videos. And any suggestions that you have, I appreciate. You can put them down in the comments. So let's look at the first one, and I'm going to make this one say true false. So I'm going to pose the problem. And then what you want to do is, these are things that you should be able to answer in probably around 10 seconds if you know or you have the foundation already for algebra. Most degree plans will require at least one course in mathematics. At the college where I taught, university where I taught, it was either college algebra or math for liberal arts. Some degree plans required both courses, some only one of the two, and you had to make at least a C for it to count. Okay, wouldn't satisfy the requirement if you made a D or lower. It had to be at least a C. So you had a good foundation in algebra in high school. These problems that I'm going to look at here should be fairly easy. So okay, the first one, what you want to do in these is think of is there a theorem, a definition, or a procedure that justifies the statement. So this is saying x plus y quantity squared is equal to x squared plus y squared. So basically saying if you have the sum of two terms and you're squaring that, you basically square each term. Okay, and you should know the answer already. This is false. Okay, there's no property or theorem or definition or accepted procedure that justifies this. You can try this out with numbers. So you can, for example, this is saying that for any two numbers, okay, in general this is going to be true. Now you can find numbers like 0 and 1 or 0 and 2. It's going to work for those numbers, but in general it's not going to work. So to make this statement false, all you have to know is think of a contradiction. Okay, so let's pick two numbers and they square them. Okay, so let's do it two ways so we can see the contradiction. Okay, 3 and 5 is 8 squared. This should be 64. Okay, no problem with that. Now if we follow this rule, it's 3 squared, which is 9, 5 squared, which is 25, and I know the answer has to be 64. 9 and 25 is not 64. Okay, so that's where that one is false. Okay, let's look at the next one. Look at it for a few seconds. Is this true or false? They're saying if you have the product of two terms to some power, in this case to the third power, basically it's taking each of the factors and taking it to that power. So x times y in parentheses cubed is x cubed, y cubed. And again, in this one, it should be clear to you if you know your basic facts from algebra. This is true. That's one of your properties of exponents. If you have any product of factors to a power, okay, and in general, this is saying if I have, say, x times y times z, as many factors as you want, taken to some power, I'm just going to call it n. That's the same thing as taking each of the factors to that power. So this would be x to the n times y to the n times z to the n. Okay. So again, think of a law, a definition, an accepted procedure, or a theorem from mathematics, in this case algebra, that justifies a statement. Okay. or find a contradiction to it. Okay, so this one is true. The next one says x to the negative 2 is equal to 1 over x to the second. True or false? This one is true. Okay, this is just your definition of a base taken to a negative power. So if I have, say, x to a negative n power, that's going to be always the same as 1 over x to the n. Okay, so this is simply saying then if you have 2 to the negative 3, that's the same thing as 1 over 2 to the third, or the same thing as 1/8. Okay, so notice if I have say 1 over 2 to the negative 3. Maybe you write this down and say, okay, let's look at this. The statement that would imply in the denominator, this 2 to the negative 3 would be 1 over 2 to the third. But of course that's the same thing as 1 over 1/8. Which is the same thing as 8. Okay, so if you look at these two, okay, so this is saying, okay, if I have 2 to the negative 3, that's the same thing. Okay, but remember, I can always make a number into a fraction just putting 1 under it. 2 is the same thing as 2 over 1. Okay, 5 is the same thing as 5 over 1. Okay, so 2 to the negative 3 is the same thing as 2 to the negative 3 over 1. Okay, so notice in this one here, looking at this is 2 to the negative 3, take it to the denominator, that's 2 to the 3, which would be 8. If it's in the denominator, 2 to the negative 3, on top I have a 1. If I bring it up, it just changes the sign. Alright, so this becomes 2 to the 3. Okay, I can still put the 1 there, but that's still 8 over 1, which is 8. Just what I have over here. Okay, so that's a shortcut way of looking at the negative powers here. Okay, look at this one then. So this is saying if 2 to the x is equal to 1/2, so we're saying then if this statement is true, then this statement has to be true. True or false? Okay. Number 3 was true because that's just a definition of a negative exponent. Okay. So we're looking for ways to justify either the definition or a theorem or an established procedure from algebra. Okay. Well, this one is going to be true because look at it this way. I have this equation is given. So how do I get this statement from this? Well, because of this negative 2 here, I could say, well, let's take this side to the negative 2. That's legal if I take the other side to the negative 2. Okay? And then here, basic laws of exponents, power to a power. Multiply the exponents, so this becomes 2 to the negative 2x. And a couple of ways I could do this one. This one I have a fraction taken to a power. Basic laws of exponents tell me I take the numerator and the denominator to that power. So 1 to the negative 2 is still 1. 1 to any power is always going to be 1. And then 2 to the negative 2 Okay. And then following the shortcut that I went over a while ago, I have 1 over 2 to the negative 2. So let's take this to the numerator. This is 2 to the second over 1. Okay. This is over 1. And let me... So negative here, take it out, becomes a positive. And then the 1 I can just leave there. Okay. This is 4 over 1, which is still 4. So here basically I use the fact that I can take both sides of an equation to the same power. And I also use the definition of a negative power. So this one is also true. Okay. Go to the next one. Okay, based on what we've done, would you say this is true or false? So look at that for a few seconds and then decide on your answer. So if you look at this, basically what this is saying is you have a 2 to the negative 3 and 3 to the negative 2. Okay, that goes to the top, this goes to the top. And then you put a 1 over here, but the 1 into anything is still this, and then 2 to the third is 8, 3 to the second is 9, 9 and 8 is 17. Is that true, based on what we talked about here, and what you know? The answer is false. Okay. Because in the ones we did, see, we didn't have this plus sign. It was a single term in the bottom. So we could say something like this. We could say, okay, 2 to the negative 3, that can be 1 over, see, we can do it this way. Okay, plus, and then the next one can be written as 1 over 3 to the second. Okay. So then this can be written as 1 over, and then this is going to be 1 over 8. 2 to the third, okay. And then the other one is going to be 3 squared there, and then 1 on top, so it's 1/9. Okay. And then we multiply by the LCD here. I'm just going to say it's 8 times 9. And then multiply the top by 8 times 9. Okay, so what do we get in the bottom? Okay, the 8 cancel here, multiplying this product here with this one, 8 cancels out, I get 9 here. And on the next term, the 9 cancels out here, I get 8. This is 17. And 8 times 9 is 72. Okay, so it doesn't come out to 17. That's why this one's false. Clear with this. Next one is this one true or false? It says the logarithm of 81 to base 3 is the same thing as 4. So the logarithm of 81 to base 3 is 4. True or false? This one is true. Okay. Logarithm basically is an exponent. So in this particular case, when it's written this way, this has to be an exponent. That if I take this base to that power, so it means that this would be legal if 3 to the 4th is equal to 81. Okay, and it is. Okay, same thing if I had log of 8 to base 2. What number is that? Okay, logarithm is an exponent. Then it's the exponent, you have to take this base 2 to get that number. Well, 2 to the 3 is 8, so this would be 3. And obviously there's going to be some where you can't do it that way, you have to use a calculator. But this is just doing some basic examples. Okay, this one is just basic math here. 50 divided by 1/2 is 25. True or false? Okay, you should know the answer right away. Like I said, some of these you should be answer in just a few, or know the answer just in a few seconds. You don't have to do any calculations other than just reason it out using what you know about the basic definitions, laws, and procedures from basic algebra. If it said 50 times 1/2, yeah, that would be 25, but 50 divided by 1/2, you invert and multiply. So this becomes 50 times 2 over 1, okay, which would give me 100. Okay, the next one. The nth root of x equal to 1. The nth root of x is equal to x to the 1 over n. True or false? And again, should know the answer right away to this one. This is just your basic definition of an nth root. This is true. So this is just saying if you have say the cube root, okay, in this case n is 3, and this could be any number. I'll just keep it in x. This should be the same thing as x to the 1/3. Okay, this is a 5, then this would just be a 5 over here. This is a 7, this would be just 1 over 7, and so on. If you have a square root of x like this, then the index, which is what this number here, 3 is the index here in this radical, this is understood to be 2. We usually don't put it in there, it's understood, so this of course is the same thing as x to the 1/2. Okay, so this is true because that's one of your definitions for an nth root. Okay, the next one basically is using the previous setup there. Okay, so it's using this result. So again, if I use this result here, which I know is to be true, is this also true, or is it false? Check it out. This is true. Okay, so it's true because, okay, let's do it this way. Inside the radical I have the square root of x, so I'm going to write that as x to the 1/2. And then what do I have? And then I have, so x then is the base for this exponent here. Now in the next one, now I have the cube root of x. Okay, so now this becomes the base now. So I'll put this in parentheses. So I'm using this result over here. I can go from a radical to a fractional exponent and vice versa. So this, because it's a cube root, this is 1/3. Okay. So now basic laws of exponents tells you that when you have a base taken to a power and a power, okay, power to a power, you multiply the exponent. So this would be the same thing as x. 1/3 times 1/2 is 1/6. Okay, so this is x to the 1/6. But using this definition, that's the same thing as the square root of x. So this is basically saying if you have the nth root of another nth root, you simply multiply the indices here. Okay, this index multiplies that index. This is 2 times 3 is 6. Okay, let's clear this and let's just do one more. Like I said, I'll have some other videos to give you examples. I've taught mathematics for many years, retired a few years ago. And these are some examples that you should know, especially your first year at college, if you're taking college algebra. Hopefully you've got the good foundation, and maybe you take calculus if that's what your degree plan requires, but most students will just take the minimum. So if the degree plan requires college algebra or math for liberal arts, they'll take one of those courses. Okay, let's do the next one. This is saying if 8 to the x is equal to 2, then what is x? So this is saying 8 to what power will give me 2? Now you should be able to figure that out also just by inspection. Don't have to do any calculations, but let me just set it up to you with for you this way. And I'm going to write 8 as 2 to the third. Okay, so I'm going to write x as 2 to the third. And then I'm going to put the x here. Okay, so 8 to the x, which is what I have here on the left side. I write it as 2 to the 3. And then on the right side, I got 2. So we're saying if this is true, then what is x over here? Now here I have a power to a power, so I multiply that out. That's 3x. Okay, power to a power, multiply the exponents. And 2, the exponent is not listed, but it's understood to be a 1. Okay, it's like when you have an x, and you just have plain x. It's understood that the exponent is 1, and that the coefficient is 1. Okay, so this is a 1. So now I have a base of 2 here, and a base of 2 here, and I have equals. Well, the only way that these two are going to be equal is if the exponents are equal. So 3x has to be the same thing as 1. So 3x is equal to 1. So if I divide through by 3, then this tells me that x is equal to 1/3. So this one is true. Okay. And you can see 8 to the 1/3. 8 to the 1/3 power. I can say that's the same thing as the cube root of 8. Which of course is 2, because 2 to the 3rd is 8. Okay, so that's one way to verify your answer. Okay, there's other ways, but that's one way right there. Okay, well, like I said, I'll have some more videos on this, maybe a part 2. And I hope this helps you out, and we'll see you in the next video. Thanks for watching.